Beautiful. So good morning, everyone. Here we are, week two of process quality engineering topics and quality. What I want to talk about today, continuation of our theme of Industry 4.0. And the topic of today is called the Internet of Things, or IoT. I didn't mention it here or say it here, but my primary focus is going to be IIoT, which is the industry Internet of Things. There are lots of IoT systems, IoT devices, IoT connections. I'm going to start very broadly and talk about sort of in the abstract a little bit about what IoT is to kind of get us grounded. And then I'll start talking about some sort of examples. And I'm not going to focus entirely on industrial IoT because I know not everybody is sort of moving into a manufacturing or an industry field. You could be moving into a service field. So I'm bringing in some other examples as well. As always, if you have any questions or comments, whatever, feel free to jump in. And as I mentioned at the beginning, I'm not an expert in IoT. I don't design this kind of stuff. I'm not part of a company that's working in this sphere. So, so my experience is somewhat limited. And, so it means if you have some experience or you have some direct knowledge of this stuff, please jump in and say so. Okay. So I'm going to talk about kind of the basic concept of the IoT. We'll talk about some applications, and we'll address a little bit about the impact of IoT. And quite honestly, it's going to impact everything. Like you'll see as we kind of go through this, that it really is remarkable in sort of what's being done. And this is only a piece of the whole Industry 4.0 puzzle, but it is a big piece. All right. So we talked through this in the last lecture, sort of building up to Industry 4.0 and sort of recognizing what I 4.0 is. And, and if you recall from last week, I talked about the idea of a programmable logic controller, that they themselves were a significant enabler to Industry 4.0, where it started to allow, sensors and actuators and automation of processes, originally of equipment, like specifically sort of machining equipment and production equipment. And then so that programmability of processes then created this huge new flexibility in manufacturing and reliability of systems. It wasn't all mechanical now, right? So I want to sort of move that a little further. So what you have effectively with a PLC system is some sort of a CPU, like a little microprocessor or a central processing unit that's programmable, and it receives some inputs from different sensing devices, switches, resistors, whatever, and then has some kind of output. So that, essentially the PLC is a little thinking device that receives some information, makes some decisions, and does something about it. All right, waiting room, joining, good. Let's see. So essentially the PLC makes the machine aware of its environment, right? Now it has sensors to pick up information. Okay, so Industry 4.0 now, and specifically the IoT, takes this whole kind of approach, leaps forward. Get my pictures in here. When PLCs were first introduced, they were local to a machine. You had a machine controlled by one or more PLCs that had, so all the information that the machine was collecting was local to the machine, like spindle speed or something like that, or the temperature of some piece of the machine, or whether the door was closed or not, and what it controlled was, again, limited to the machine. It controlled the motor, it controlled the bed, the XY axis or something like that, right? But it was local to the machine. So now Industry 4.0, and this is just sort of a fictional diagram, imagine a PLC-like device that doesn't just communicate with a machine and doesn't just take information in about the machine. It takes in any kind of information and communicates it to some sort of a central system. And I've intentionally drawn this like a cloud because this is part of Industry 4.0 is kind of cloud computing. So the information now becomes shared between machines and really between anybody who needs it and who has access to it. So now you have these kind of smart devices and they're all sort of connected. So you have a machine in some building that's making decisions, like little CPUs, making decisions on whatever inputs that CPU is accessing, and making decisions and outputting some information, and the information is being shared into some central system. A machine and another machine in the same building, a different machine or a furnace or whatever it is in yet some other building, some conveyor belt somewhere else. I don't know, like even the HVAC system in some other building, right? There's no limit because it's all connected effectively through an internet-like system. Could be literally the internet or a local area network, right? And so now you have all this sort of connection between all these different inputs and outputs, information and data flow. All right, and then take it one step further. Like now we move beyond just machines. Then they could be stoplights, they could be cars, they could be the watch that you're wearing, any kind of a transportation device. They could be satellites, they could be cameras, they could be control system for buildings. It opens it up, and it doesn't matter what it is. You'll have, but the basic components are all there. They're no longer PLCs, but they're microcontrollers with some sort of input and some sort of an output and some sort of a computational power communicating some piece of what it's aware of to some centralized system. Okay, so you can kind of see this explodes in a hurry. Between local and wide area networks, the Internet of Things can now share information between themselves, which leads to more sophisticated and customized decision making. So imagine now, so this is the idea that anything anywhere can trigger some activity anywhere else of any other thing. So a sensor in a plant in China or a grocery store in Florida can now be used to trigger an event or a decision here in Kitchener or in Mumbai. Like it doesn't, right? Somebody pulls product off of a shelf on a store, that piece of information can go to the manufacturer and they can see who is buying what, when, how often, in combination of what other things, and start prediction of what to produce tomorrow. It's rather astounding, actually. And what I'm talking about is not science fiction. Like this is genuinely happening. For example, the Amazon company, which love it or hate it, is dominating so many markets right now. They actually, based on your use of the internet and your sort of your viewing, just not even your shopping trends, but what you view, Amazon is using to pre-stock items on the shelf. So, and they are predicting what you and I are potentially going to buy from them, or what the trends will be for purchasing decisions in the future. And Amazon will predictively stock those items.
Yeah, they check on your routine. on everything, whatever you buy mostly and what you like, and then they focus on you all the time.
So it's remarkable, and you know how so all this information that they have and they're using to make these sorts of decisions. But there's also, you know, stores which are like there's no cashiers. You walk into the store, you take items off the shelf, put them in your cart, and you leave the building. And you don't have to talk to a computer. You don't have to talk to a human. You don't have to bring your credit card out of your pocket. The store knows what you've retrieved from the shelf, and it will charge you on your way out of the store. Like these are live, up and running today in more than one location. Okay. I've chosen this. This is a short video from Siemens, and this kind of introduces the IoT concept in an industrial setting.
A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first SIMATIC. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
Fabriken werden zukünftig aus Bausteinen bestehen, aus smarten oder intelligenten Bausteinen, wie man es nennen mag. Vergleichen wir das vielleicht mal so ein bisschen mit einer Lego-Steinwelt. Das heißt, wir haben standardisierte Bausteine, die wir hoffentlich relativ einfach zusammenstecken und zusammensetzen können. Jeder dieser Bausteine hat bestimmte Funktionalitäten und wir können sie zukünftig in einem solchen fabrikinternen Internet dann kombinieren.
A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Wenn Sie sich das Thema Industrie 4.0 angucken, dann basiert sie ja auf der Logik dieser Cyber-Physical Systems. Das heißt, Sie haben autokrate selbst arbeitende Systeme, die sich optimieren und sich gegenseitig austauschen. Und dadurch letzten Endes Produktion optimieren.
Ja, die Vision sieht so aus, dass wir ein Internet quasi hinunterziehen bis auf die unterste Ebene. Das heißt, jeder Sensor, jeder Aktor wäre damit quasi ein Teilnehmer eines Internet der Dinge. Jedes Gerät hat damit eine eigene IP-Adresse, ist damit adressierbar in diesem Netzwerk.
For the customers, this means tailor-made products at relatively affordable prices. For industry, it means highly flexible mass production that can be rapidly adapted to market changes, because in the future, product life cycles will be even shorter. Another reason why it's increasingly important to depict engineering across the entire life cycle. Maintenance, for instance, is planned in from the very start.
Wir haben ja bereits in den 90er Jahren mit Totally Integrated Automation entsprechend ein Setup gewählt, wo unsere Produkte und Systeme sehr gut miteinander kommunizieren können.
At Corporate Technology in Princeton, a cyber-physical control is being researched even today. The vision, the control, and all linked sensors are connected to the Internet.
One potential scenario is enabling the PLC to react to utility pricing information in building automation. We can enhance PLCs to use simulation to calculate how much to pre-cool a building, with the ultimate goal of turning off the cooling system during peak times.
But that's just the beginning.
We've prototyped capabilities in a PLC to access big data in cyberspace in real time. And we've also enabled a network of PLCs to connect to a dynamic simulation of the entire physical process.
Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.
So this video is a little old, right? This is 2013. And this is, to me, what's kind of remarkable. Here's Siemens, which has always been on the forefront of this. This is one of the leading manufacturers of the PLC devices themselves, right? So one of the forerunners of the Internet of Things, and especially the industrial Internet of Things and connectivity of devices. And here in 2013, they are just visioning this stuff. Imagine, this is now only 8 years ago, 7 years and 2 months ago. So we are really we're still in this groundbreaking vision of this. This is already multiplied. Siemens is doing this as a demonstration of what the Internet of Things can do. And we've moved beyond now demonstration. Companies are employing this. This is now, it is not commonplace by any stretch of the imagination, but it's certainly being used in bits and pieces around the world by real companies in real processes. Okay, so there's a couple of key points that have been illustrated by this notion of cyber physical systems, this collaboration or communication between the machine, the item itself, and the person. And this sort of three-way collaborative effort is a key part of this whole Internet of Things and Industry 4.0 kind of concept. Rather amazing, isn't it? Like, it's pretty cool stuff. Let's see. Yeah, so here, one of the things just to notice in this video, the product itself controls the process, not an operator. So it does not bode well if you're the operator. But there are massive opportunities if you're the engineer.
That's why they predicted in Japan that in 2030, that is about 9-10 years from now, there'll be about 20 million people will be out of the job because everything will be controlled by PLC and robots. Total automation.
Yeah, I see actually, so I've looked at studies of robotics. We'll actually talk about it when we get to the robotics, and you'll see it's China that I think is at the greatest risk in terms of employment of operators in plants. China is the country that is implementing this the fastest right now, in terms of robotics anyways. But yes, it's changing the face of industry, and it's changing the nature of work. Okay, let's see. expands the awareness of a machine or any device beyond the sensors and switches directly connected to the device. Yeah, so instead of one machine or device working in an isolation, it communicates with all these other devices, shares its own data with other devices. Okay, so this is what I'm talking about, this partnership between man, machine, and product. That's what, so if you do a Google search, you know, the way to look for this is called cyber physical systems, this man, machine, product kind of integration. Is one of the key concepts, and that's what we're going to explore a little bit more today. So multiple independent sources of data shared with multiple independent systems. One of the things that it pointed out in that video is that every device then has a unique identifier. You know, it's a thing in this Internet of Things. And so frequently that thing identifier is an actual IP address, just like your phone, your computer, your laptop, and your watch maybe all have an IP address on your internet or intranet. So too with the Internet of Things. Okay, then sensors. They can be anything from like cheap disposable to very complex and sophisticated devices. It doesn't matter to be a thing. There's no restriction on what can be a thing on the Internet of Things. And then all these inputs and outputs are then typically connected 24/7. It can be raw material suppliers, manufacturers, operators, managers, machines, customers, the public, whatever. You know, you may be feeding the Internet of Things and not even know it. So this is from I thought a fairly good piece of literature, although it's a little old now, 2015. A global network allows communication between human to human, human to things, and things to things, which is anything in the world, providing a unique identifier to each and every object. Sensors and actuators embedded in physical objects, from roadways to pacemakers, linked through wired and wireless networks. So this is the you know, where I'm going to go with you guys, and I'm going to make this an assignment of yours, to focus in on this fundamental concept of sensors and actuators, because that's really at the heart of this. Is that they're not just like the thing has to either sense what's going on around it and share that information on the network, or it has to receive some direction from the network and do something. Right? So fundamentally, the Internet of Things is broken into sensors and actuators. In its simplest form, the things that make up the Internet are either sensors or actuators. Sensors meaning something that takes an input, actuators something that is a doer or having, pardon me, some sort of an output. Okay, well, sensors and actuators aren't new. We've had proximity sensors, distance sensors, pressure sensors, temperature sensors, blah, 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 for decades, right? That's not new. And we've had motors and relays and solenoids also for decades. That is not new. What is new with the IoT is that these sensors and actuators are no longer hardwired. You know, before it had to be like physically wired into the system, and you would take the electrical signal from the sensor and run it through some sort of a circuit board, and it would then trigger some actuator or something like that, or through a PLC would make some local decision and affect the actuator. But now disconnect them physically and reconnect them through a network, give them an address, give them an identity on the Internet of Things, and let them communicate. There are all kinds of ways, like near field communications, Wi-Fi, Bluetooth. I think from, again, I'm not an expert, from what I'm seeing, but low energy Bluetooth is kind of where a lot of this is going, like either between Wi-Fi or being connected to the internet and for sort of communications within a building. I think low energy Bluetooth takes you to about a 200-meter range, much more than like a standard Bluetooth is about a 20-meter communications range. right? So if you leave the room, your Bluetooth device will disconnect. But with about a 200 meter of this low energy Bluetooth, it means that you can have proximity and communication going on within a factory now. All right, let's see. This is kind of basic, right? A sensor detects events or changes in the physical environment, all kinds of different ways: temperature, sound, heat, pressure, right? On and on and on. Most sensors take analog inputs and deliver a digital or encoded output, and those are crucial because the idea of making intelligent decisions, you have to make decisions on data and on input. So you'll find that the world is being flooded with sensor devices, connected devices. So they could have some really, like, they could be very simple, just collecting and transmitting data. But I think the trend that I'm seeing is that IoT sensors are now becoming smart devices. So they, on board, start to filter out information, whether it's sort of duplicate information or maybe I'll talk about in a minute, even more sophisticated than that. So it'll only notify the network when some very specific conditions are met, right? So the sensor itself, it has a sensing element, then some sort of a microcontroller is looking at the sensory feed, making some decisions, and then sending on what it decides to send, right? So it's not just a temperature sensor just constantly sending a temperature every second. It might say, well, here's the temperature, and I will send it again if it changes by more than 5 degrees, or I'll send the information if it's crossed some threshold. Otherwise, I'll just send a no change, piece of data or something like that. How am I doing, Katie? Am I so far so good? All right. You're my gatekeeper. Okay, so then you need some sort of a programmable logic on the sensor itself to be able to do this. One of the cool things that I've seen, let's see, I'll cover it in our module on artificial intelligence. But for example, a camera, I'll show you a camera that has artificial intelligence built in. So instead of the camera then transmitting like a video feed, like it's a video camera, right? Not just a digital, not just a snapshot, but a video camera. Instead of sending the video feed to the network, it looks at what it is seeing and will decide what it is and will send on a name of what it sees and where it sees it in its vision. So it will, right? So imagine the reduction in bandwidth. Instead of sending a whole video feed and then leaving it up to the receiving end to figure out what this means, it says, oh, look, I see a stop sign. Oh, look, I see a pedestrian. Oh, look, I see a snowy day. I see a yellow line. I see, right? Or I just saw like a young male customer has walked in the door with 2 female customers.
That's all the knowledge has been provided to the machine.
Yeah, of course. And so it requires training. It requires all kinds of things, which opens up, and this is what I want to point out in this course. That provides opportunities for people. They don't get smart on their own. Somebody has to teach them. Somebody has to understand this stuff. Somebody has to develop these and make them work. But yes, you ultimately end up with this very smart device, potentially with artificial intelligence capabilities, to make decisions about what it's seeing and then send those decisions on.
So imagine when it gets a breakdown or a bug or a virus in there, and
Yeah,
the whole system
somebody else is
shut down.
employed who has to go and fix it. Okay, so you'll find this, from the simple to the complex. Here's like a simple pressure sensors, for example. These rose mount flow, level, and pressure sensors. So you get a local operator interface, built-in diagnostics, and they're wireless, and so they allow remote monitoring of whatever kind of an industrial application or system. I don't know if has anybody here heard of or played with the Arduino or a Raspberry Pi? Yes, a little bit or a lot, Katie? Experimented?
Yeah,
expert?
I play with that.
You have as well? Yeah.
I have one.
Nice. So what's your experience?
It's good. For the small kind of project, we can use that because it's a microcontroller, so we can, yeah, like that.
So, right. So this is just a little, that's an Arduino. What kind of, and so have you done any projects with them yet?
Yeah, I done with that. Actually, I use in the car for Bluetooth operating car. So we can start with our mobile, our automobile car.
Yeah.
So I use this Arduino for that.
To have a little card that follows like a tape line or something?
It's automobile car.
Oh, a real car.
Yeah, real car. We
Okay.
can start with the mobile.
Oh, yeah, I gotcha. Like a remote starter.
Yeah, remote starter, and we can turn on the radio, or we can turn on the interior lights.
Yeah, beautiful.
Any more, yeah.
And these come in all kinds of shapes and sizes. This is sort of about a standard package size for an Arduino, but this guy is an Arduino Nano, so a little smaller. And the crazy thing is, like this Nano is like $7, right? Like, so they're super, super cheap. And then what you can do is get, like I'm showing here, this sensor kit. What do I have? Sorry, I didn't really organize this for, yeah. All my stuff is sort of buried in here. Okay, anyway. So you can have, well, like this little guy here is a temperature and humidity sensor. So you can do, like, to start out with, you just do like simple breadboard projects. Like, I'm just learning this stuff myself, but it's kind of fun. So you can buy like a package like this for about $40. And you get this whole package of sensors. So the one I'm pointing to here is this little humidity sensor, right? So these are all sort of less than, I don't know, like less than 30 centimeters by 30 centimeters kind of thing. And so you just plug them into a breadboard and you wire them up to your to an Arduino. If you want to make it an IoT device, then you can hook up something like this, like a Bluetooth module or a Wi-Fi module. Or now some of these, I've got one of mine here is actually got the Wi-Fi built in and the Bluetooth built in to the Arduino board. And so when you buy a sensor package, and now you've got a microcontroller receiving barometric pressure, temperature, sound, proximity, light, humidity, infrared, motion, pathway interruption, angle, tilt, gyro, acceleration, whatever you can imagine, for like less than $50. So you paid how much to attend this program? You paid $16,000, right? And you got $50 left? Or do your parents have $50 left? Joking aside, to me, this is an investment. Like, to me, this could be an investment in your future. Spend $50. Buy an Arduino, or and honestly, buy the cheapest ones you can. Like these little this Arduino Nano that I showed you. These little guys, you buy a box of 3 of them for I think $12 now or $14, and it gets you 3 of them in case you blow one up, right? You miswire it or something like that, and then you can communicate with you build. There's all kinds of instructions to connect it to your phone, run it through Bluetooth, connect it to your internet, power it with a little 9-volt battery, and you're off to the races. And you have your own thing on the Internet of Things. And
I feel sad that all this is coming out because in my days, I was involved when it was first started. Like I told you about the project from Ireland to Pakistan.
yeah, nice.
Yeah, and then I moved to a different career, and now I really see all these things I miss. That it's time to go back, but now all these years have gone by. It's hard to go back now.
Do it anyways. Do it anyways.
Because my closest friend, he uses Raspberry Pi, and he's programming things before he comes home. The hot shower is ready. The microwave turns on. Before he enters the house, the food is warm and ready. He just goes into the shower. Everything is done without wires. Amazing. Amazing. Yeah.
So one of the things that I want to point out to you, and why I'm sort of confident in pushing something like the Arduino, it is open source. So basically that means that there aren't patents on this. The company who developed the concept has made it open source, which means that anyone is allowed to manufacture an Arduino compatible system, whether it's sensors or the actual sort of motherboard itself. So these aren't, let's see, like this is not a genuine Arduino, it's a free Nova out of Italy. This whole system was sort of invented in Italy, but it makes them cheap, right? I have no idea how they manufacture something like this for $7, but they do, and they still make a profit off of it. And so it means it's very, very approachable in terms of access. There are literally hundreds of sources where you can buy the stuff. The prices are very low, but also there's a huge online support community. So projects that you can just follow completely. The robot I'm building, I didn't invent it. Somebody made the 3D drawings available to print. And they've made all the wiring diagrams available. Have a video walking through on how to assemble it, and the code on how to run it. So it's not like I'm a genius in using this. I can just follow instructions, and I buy the stuff that's in the bill of material, and so this is, I would say, highly accessible to you. And if it's something that interests you, this is I would say for a modest investment, this is something you should consider. Okay, so let me switch gears. That's sensors. Now let's switch gears quickly to actuators. So these are the doers of the IoT system. So things like motors and switches. Again, they're sensor controlled. They use data that's been analyzed through this sort of intelligent system. And for example, you can shut down a gas flow when some measured pressure is below a threshold, or you can move a robotic arm or select a paint color. You can start a production cycle when inventory is low, or in a car, you can apply the brakes when a stop sign is recognized, right? They're independent, computer-controlled, microcomputer-controlled devices. Act on your immediate environment. Let's see, what else do I want to say? So they're broken down. This isn't important to, like, there's no test in this course, so you don't have to memorize any of this stuff, but I want you to sort of understand the concepts. There's linear actuators, motors, relays, and solenoids. Each one does different kinds of things: push, pull, move, switch, whatever. And then you get servo motors. I got one out of the bag. Anyway, so a simple thing again, back to the Arduino, is you'd buy little motors like this, right? And then you can run them, slightly larger ones that you can run little robotic arms or make movements or turn things on and off or push things around or push the on button on your kettle, whatever you want. So I'll talk about some more industrial applications, but I'm going to come back just before I leave this concept of the Arduino. Not only can you buy sensors to plug into the Arduino, but you can buy actuators to be controlled by an Arduino. So if you could have an Arduino with a sensor in one room, controlling through your intranet, through your home intranet, a motor or a relay or a linear actuator connected to another Arduino in another room, right? Or like somebody said, you get connected to your bicycle. So when you get home to your apartment or something like that, it unlocks your door and turns on the coffee for you. I don't know.
I've seen a good example of this in a Italian blow molding machine, which is called Magic. So you can see Magic machines have all these features in a blow molding and an injection molding machine.
So is Magic the company that makes the IoT sensors and actuators? Or?
No, they make blow molding machineries. So they use all these things, Adreno. Using this, they actuate everything. They make the heaters start at a time. They start the motor with this without anyone in the plant. And when the operators and everybody, technicians come around in the plant, everything will be ready because it takes 4 to 5 hours for the preheating thing. So that's how it works. All the relays are controlled by Arduino.
Nice. There you go. Is it Magic, MAGIC?
Yeah, there are lots of examples. MAGIC, Magic.
Yeah.
That's the best example. And now Taiwanese are very good at it. You can go ahead and look into Parker, which is they have good videos of missions in YouTube. Parker, Parker.
So Parker as in Parker Hannifin?
Blow molding machinery.
Yeah. Okay.
Yeah, it's a blow molding machine.
Cool. Yeah, awesome. It's fun to see all kinds of applications. Like it's limited only by your imagination. This is what's so cool about this is, this is such a generic thing. Any sensor that's smart, connected and sharing its information, controlling any device that's smart and connected, doing whatever the heck you want it to do. All right. And these things are cheap. Like, so $19 gets you 5 little microservers, right? One's for coffee, one's for tea, one's for the front door light, one's for the door lock, one's for, I don't know.
There are technicians in bigger industries and corporations. They fix all the machinery straight from home or wherever they are around the world. And there is an issue, so they just connect via internet to the link of the processor which is in the plant, and they can know which one machine, where is the problem with the red and green PLC signs.
Yes.
And they fix it from there only, and they don't even have to be there. So that's how everything works.
I used to be responsible. So absolutely right. Yes, of course. Like maintenance and preventative maintenance is massive. I have actually another short example coming up on that I'll touch on. There was we installed a very sophisticated heat treating process at a company that I worked for. I was responsible for commissioning it. We installed this system. It was very cool. We had patents on it. It was really neat. I could literally run it from home. Like it had a video camera at the top. It was all computer controlled. I had a digital screen that showed me what was going on. I could visually see to confirm what was happening. I could start cycles, reprogram cycles, change it from from my house. And this was 10 years ago. Okay, like I don't need to explain. Like Google Home or Alexa is a a trivial example of the Internet of Things that you may have already experienced at home. It's an internet connected device that controls other internet connected device, receives signals from the user, from the homeowner, and does whatever, right? Tons of these different sorts of things. I actually had a much more expensive, like an industrial duty, one of these things in my office. So this is HP now. That's installed it on even their like cheap inkjet printers, like a $200 printer. They called it instant ink. So the printer knows when it's about to run out of ink, and it will order ink for itself. So I had like I said, I had an industrial version of this. I don't think it was an HP printer. I had an industrial printer in my office. We had them throughout the plant, and I never ordered supplies for it. Every once in a while, somebody would just show up in my office with ink cartridges and replace them because the printer itself ordered supplies. Okay. I think, Katie, you'll have to tell me if this is anything like what you were dealing with. So in terms of like fleet management, this is an application where it's monitoring temperature, whether it's got cargo in it, tracking the trailer itself in terms of GPS, what's on board, safety cameras, controlling the locks and the doors, even maybe controlling the suspension through the hydraulics, tons of kinds of things. You were doing you said BlackBerry, I think, right? What kind, and I have to remind us again, what kinds of things were you sensing?
So it was actually a bunch of the things that are on this diagram here, but it was a brick about this big that attached to the back door of the trailer. Right. So it would have had like location tracking, and it had a time of flight sensor, so that it could see how far, like how deep the trailer was packed at different times to see if things had been removed.
Yeah, okay.
It was certainly doing temperature and humidity, and I know that it was sensing when it had last been opened. I don't remember whether that was vertical momentum or a light sensor.
Yeah, beautiful. Right, very cool. And was it, and how did it communicate? Like, so it had was it just storing the information on board, or was it through sort of a satellite uplink?
It was a satellite uplink. So it was every maybe 5 or 10 minutes, you would get an update on all of the trucks in your fleet. Beautiful.
Okay. This is actually, so this is, I think, when you're talking about this brick, Katie, I found this video of the sort of tracking bricks that you're talking about. And I thought that this was pretty cool.
Introducing one of the stars of this film. Okay, as heroes in the opening scene of a film go, you may think this little box is pretty unremarkable. But in actual fact, this little guy and his buddies pack quite a punch. Since OmniID developed the world's first on-metal RFID tag in 2007, we have been pioneering tracking and monitoring technology in a huge range of different ways. You'd be amazed at all the places our devices are now used. Shall we take a peek? Whether they're attached onto shipping containers to track...
So that's the kind of thing you're talking about, Katie? Like,
yeah, that looks a lot more slick than the one that we were on, because we were doing more of we were still in the prototype phase when I was on that project, but that's, yeah, basically they look like brothers.
Yeah, there you go. So tracking the movement and location of containers over long distances. Oops. Uh-oh. This is the sorry,
Assets across the globe or used in the yard to monitor workers' movements.
Yeah, so it's subtle here. It's circled, so he's wearing a lanyard, and it's not it's not keeping track of the cargo. It's keeping track of the employee. And I don't know if it's got a little shock sensor in his shoes, you know, if he's taking too long of a break, but it's tracking where the people are as well.
Our devices are pretty used to multinational travel, from the seas to the land to the skies.
Right? Distance and accuracy of golf shots built into a golf ball.
And everywhere in between.
Monitoring aircraft engine temperatures, location, speed, and temperature of the vehicles. Oh, here, it's tracking, so an alert button for your hotel room, but it also knows what's in the bar fridge and whether you've taken snacks out or a little Mickey of scotch or something like that.
Oh my goodness.
Or do you still have toothpaste, you know?
Our devices are harnessing all the latest
locating pipelines, data on how long they've been in use.
communication technology and can be deployed in a range of ways.
Inside beer kegs, clipped inside the chime of a beer keg so it can be easily identified.
Ways to track and monitor intelligently.
Right, locating products, locating machines.
And we're not just limited to global usage. We're in space too. To find out more about OmniID's intelligent tracking and monitoring devices, visit omni-id.com.
Okay, enough of the commercial. But so this is kind of how far, like, this is now commonplace. This is just a company. Yeah, we make sensors and bolt on, clip on, magnetic on, wear on, built inside, whatever, for asset tracking and moving. So imagine though, you know, if you're working for a company, just imagine, no matter what company you join tomorrow, imagine what you could do with these kinds of a thing. Put a sensor on anything you want and know where it is. A product, a box, a machine, a forklift, like whatever you felt like tracking, you can track it. And right? to me, I find this stuff astounding. Like, and it's brilliant, and it gives you so much newfound power. And this is sort of my recurring point to you. This is, you know, to me, this is the School of Workforce Development. So my role is to help develop you as an entrance into the workforce. And I will say from experience, if I had an intern or an engineer work for me who said, you know, we're trying to track these products and figure out because they're moving slowly through the plant or we're losing track of something, could we invest $2,000 and buy some tracking systems that would tell us where these products were within the building, and we could query it with our phone or on your computer, and we could log every 5 minutes and know where it was and superimpose it on a map of the building? Would that be helpful? Like, do it. Like, do it tomorrow. Like, this is, you know, it's brilliant. I would love that. Yes. And the thing is, if you work for some, you know, you work for some old fart who's been there for 20 years, they don't know how to do this. And no offense to us old farts, right? But the people who already work there, if they're not experts in this stuff, they aren't thinking of doing this themselves. And so it takes, you know, I'll say sort of the newer generation. Well, it's not about age, right? It's about people who have some knowledge in this and some interest in this. It doesn't matter how old you are. I could do this, right? But even more valuable if you're trying to enter into the workforce and make a name for yourself and get a role. These are opportunities for you. Okay. So I think you talked about like preventative maintenance and inspection. So here's this idea of a low energy Bluetooth gauge. So we'll direct it back into a quality sphere and quality control. So I thought this was a good example.
Here in Vienna, we produce light rail vehicles for the worldwide market. We also perform services contracts for locomotives. In the past, when we tested the vehicle functionality, it took us 5 days for 2 testing engineers. In the solution with Testify, now we're able to do the same tests within 3 days with only the equivalent of 1.5 testers. So this is an improvement of roughly 50% on the testing time.
Testify consists of 3 main components: digital checklists, issue tracking, and reporting.
Testify is a perfect example of a connected solution. It brings near real-time information processing, efficiency improvements, and easy integration across systems and data sources.
Companies do have tremendous time savings in doing all the things that we've done before on paper with our solution in a digital way on our tablet in real time, backed up with a Microsoft Azure architecture. If an employee finds an error on, for example, a vehicle like this, he can make a photo, then he can choose as an employee which has to repair this error. After that, he can choose, for example, a category, make a comment, and from all this data, which is tracked in real time, a quality manager can afterwards do all the reporting and analysis in real time. To integrate our solution in other devices or solutions, we developed the Testify IoT box, which communicates with the Azure IoT Hub. And in this case, we can easily integrate sensor data, machine data, or even communicate to other systems like SharePoint or Microsoft Power BI.
We use it for testing the vehicles, where Testify helped us to automate a number of tests. And we use it also for the final inspection of the vehicles, where we were able to eliminate the paper checklists. We also wanted to base this solution on a trusted platform such as Microsoft Azure. With Testify...
Okay, after this it turns into a commercial. So, so I would say, even in terms of quality control, like if you're not thinking about industrial engineering, but your role is very focused on sort of QC, quality assurance, my experience is that this is already creeping into the world of inspection, in-process inspection, unattended inspection, right? So you don't have to have an operator measuring something. You can have just this sensor there. It could be integral to the machine, but it also could be just something you add on, and it's sending live data back to a central system. And so now you can do process monitoring and quality monitoring remotely, and dispatch a human inspector or something like that, or technician or whatever to go and see something if your process is going out of control or whatever. So, you know, the applications are absolutely there for quality assurance and quality functions as well.
We eliminate...
Okay. Good. So let's see. Yeah, so this industrial IoT, this is sort of what I'm moving into now, where you have, you know, machines, whatever kind of equipment it is, and they all have some sort of a wireless or Bluetooth or near field communication sensors, all going through some sort of a gateway, all coming into some cloud server or some sort of a local hub for data processing, analytics, and either just analyzing it, like that's a first step is just to see it and analyze it and track it. And then the next step is then to make decisions and pass that back out through the internet and make some changes, make some adjustments to your process or control the system. So this is the production magazine, production machining magazine website, what have you, in that wrote this article recently. During the next decade, digital manufacturing technologies enable the companies to connect physical assets to create a flow of data across the value chain. Right? So the whole value chain is from raw material suppliers through production into packaging, final assembly, and out the door. From design, sourcing, and production, distribution, point of sale. Yeah, and then the end user. So I haven't really focused on this, but the IoT extends past the factory. And when you've delivered the product, it may still, like, certainly your phone is a great example. It stays connected, but your phone isn't the only thing that will auto update, and the manufacturer can push updates to your device. Like, certainly vehicles are a great example for that. When you buy many modern vehicles, like if you bought a 2021 model of a car today, I don't know what the odds are, but I'll say more and more vehicles are staying connected to the OEM. And so if there's a safety update or some sort of update that the company comes up with, they will push it to your vehicle. They'll push it to your car. And so it could change programming of the suspension system. It could change the programming of the fueling system or the emissions control system, or what have you. They've even talked about being able to, in a vision where the car can be upgraded on demand. So if you're actually going on a road trip, you could pay for a temporary upgrade to your car. It would be pushed to you, and you would basically rent the upgrade for the duration of your trip, and you would have a nicer car to drive for the next weekend or something like that. And it'd say, access to a cellular network, be able to watch Netflix in the car, have better air conditioning, a better sound system, better suspension, better performance. A service package, a 24-hour roadside assistance until next Tuesday. So,
what a world we live in now.
Oh, it's amazing. It is. It's remarkable. So we've already touched upon it. Connected factory, automated inspection, sensors on the product, analyzing. Just everything. Analyzing the whole flow, analyzing the processes, how well things are going, how quickly things are going, who's doing it, when is it happening, what does the product need, where is it going, all of this stuff. Just remarkable. And so I'll just touch on, it's not just manufacturing industry. Oh, thank you for the link, Bharath, to Magic. Awesome, cool. But in terms of services in healthcare, so I chose this one because it might be something that a lot of us can relate to. Whether you're wearing some sort of a smartwatch, whether it's a Fitbit or a Google watch, mine's a Tick watch. We're going to get to the point where these devices will track more than just your step count and your heart rate, but blood oxygen saturation, skin temperature, blood glucose. It'll track your eating habits. It can monitor your breathing patterns. They're talking about implantable sensors that would go under your skin and could monitor blood glucose on a constant level. So if you have diabetes or any other particular issue, then of course there could be remote monitoring. So you could have a healthcare worker actually check in on you digitally. If there's an issue, like if you're a senior or something like that and you fall, your device will detect that you've fallen and will call for help on its own. It'll make that decision on its own. And then if you're interested, you can look at, if you Google biobank, you'll see that there are a remarkable number of biobanks located around the world that are just storing data about humans, what we eat, what our x-rays look like, what our tissue samples were, what our hospital visits were like. And it's all available as data, anonymized data that's all being input from the healthcare industry. So it's it's kind of everywhere. All right. How am I doing here? Good. Okay. This video, so I apologize, this video is a little longer. It's about 10 minutes, but it kind of looks ahead at where IoT can go, just to give you sort of another taste of possibilities. When this video is over, then I'm going to switch gears. This is the last thing I want to show you about IoT. And then I'm going to switch gears and we'll talk about the first assignment for this course, which is an IoT assignment. So, how's the volume on these? Is this okay, these videos that I'm showing? All right. This one I might expand to full screen. Actually, you know what? I'm going to switch to YouTube and we'll do it in a full screen.
If you want my help this year to
You're gonna have to put up with a couple
significantly
commercials
upgrade
on the
your
way, I think.
productivity, your happiness, your vitality.
Yeah.
The world's most valuable resource is no longer oil, but data. The quote from The Economist in 2017 holds true even more so today. Data in the 21st century is like oil in the 18th century.
Sorry, and we're going to come back to this. This notion of big data is one of the elements of the Internet of Things, or of Industry 4.0. And so I actually have a separate lecture, and we'll talk about big data and data analytics.
As we've seen in our previous videos, Internet of Things is one of the pillars of the fourth industrial revolution. With the increase in adoption of different technologies such as machine learning, augmented reality, cyber physical systems, and Internet of Things, the world of digital transformation is about to take another leap in the next few years. According to the famous futurist Ray Kurzweil, we are living in one of the most exhilarating times in human history. The evidence of dramatic change is all around us, and it's happening at exponential speed. Humans are linear by nature. We tend to link events up logically in a linear flow through space and time, so it is difficult and against our intuition for our minds to comprehend the technological changes that are happening now. So here's another way to think about it. Take 30 steps linearly and you get to 30. 1, 2, 3, 4. Step 30, you're at 30. With exponential growth, it's 1, 2, 4, 8. Step 30, you're at a billion. So taking 30 linear steps is not going to get you very far, but taking 30 exponential steps will be the equivalent of traveling around the world 26 times. The fundamental measures of information technology follow a surprisingly predictable and exponential trajectories based on the Moore's law. In 1965, engineer Gordon Moore predicted that the number of transistors on a chip would double every 2 years. More than half a century later, this trend continues despite predictions that it cannot last much longer.
Yeah, so I apologize. We're going to have to put up with
Build custom industrial machines.
Computers have been shrinking from filling up a room to filling up your pocket, all while becoming way more powerful and cheaper. The technological advancements around the world is directly proportional to the growth of global automation, which is driven by the Internet of Things and cyber physical systems. These systems will provide the foundation of our critical infrastructure, form the basis of emerging and future smart services, and improve the quality of our life in many areas. While Internet of Things takes care of the connections between objects and machines to the Internet, cyber-physical systems are machines in which a mechanism is controlled or monitored by computer-based algorithms. Other phrases that you might hear when discussing Internet of Things and cyber-physical systems are smart anything. Manufacturing, agriculture, cities, buildings, homes, pills, you name it. Connected machines will interact, visualize and make decisions autonomously. One of the data sources that feed the algorithms comes from the smart sensor systems in real applications. For example, in the healthcare sector, the data collected by smart sensors can help medical professionals understand critical situations faster and more accurately, and enable patients to be more informed about their conditions and improvements. The data, along with the devices themselves, are creating the Internet of Medical Things, a sophisticated health tech ecosystem that will pave the way for new technologies such as medical kiosks. When you think of medical devices, you often think of devices such as blood pressure monitors, glucose systems, or smartwatches. However, the US Food and Drug Administration have approved smart pills with an ingestion tracking system. The global smart pills technology market is expected to register a substantial growth in the future, owing to the increased prevalence of gastrointestinal disease, sedentary lifestyle, and high patient compliance on account of minimally invasive techniques. The medicine of the future is expected to be data-driven and, thus, highly personalized. The AI-based computerized diagnostics will basically change our comprehension of well-being. But that is not all. According to Kurzweil, we can scale the devices down to a few billionth of a meter. He predicts that by the end of the decade, we will have cell-sized nanobots in brains that connect us to the internet. There are already companies that are working on implant devices.
Anybody guess who is working on implant devices? What the company is? Pick a large company that's got a lot of advancements in AI and internet connection.
Elon Musk?
Yes, got it in one. Which kind of scares me. Should scare
Like
all
he
of us.
can achieve, like, I don't know, he can achieve, but the things which he has told to us, like he has achieved everything. I don't know he can do it or not.
I'm just not convinced that he has our best interest at heart.
Yeah.
Which connect the computers.
Everything's comes with
Neuralink,
explosion.
which is founded by Elon Musk, is developing implantable brain-machine interfaces. These brain-machine interfaces hold promise for the restoration of sensory and motor function and the treatment of neurological disorders. Researchers have demonstrated human neuroprosthetic control of computer cursors, robotic limbs, and speech synthesizers using no more than 256 electrodes. Musk thinks his direct brain-to-machine interface would help humans avoid becoming house cats to artificial intelligence. Humans, like computers, could be updated with additional intelligence in the future.
Did you catch that? Humans, like computers, could be updated. As long as you maintain your subscription.
I guess they are playing with nature now. Wow.
It's already happening, man.
It already happened. There is this, what is it called? When your kidneys fail to function and they implant you with machine kidneys and your heart and your lungs and your limbs when they are like not functioning.
Yeah.
It already happened.
Just don't stop making payments. I mean, it's fantastic, right?
There will come a time the payments won't be necessary.
A long time from now.
Yeah.
A long time. That would be wonderful, but well, that would be interesting, but a long time from now.
Most of them predicted it will happen in like 3 years.
It won't be the payment, then it will ask for bitcoins.
Of course, it'll all be bitcoins, but then somebody will hack it. I mean, and this is actually, so this is why I don't cover it in this course, but one of the other elements of Industry 4.0 is cybersecurity. So you can imagine you are now walking around and your leg, your heart, or your brain is literally connected to the internet, and the opportunity for hacking that is beyond frightening. So cybersecurity is a huge part of Industry 4.0, but I've chosen not to cover it in this course because I kind of feel it's beyond the scope of what we're taking as engineers and an industry application sort of thing. That's probably for somebody else to deal with, but we certainly need to be aware of it. Okay, here, let me continue.
This is not the only frontier that Elon is involved in. Besides Neuralink, Musk co-founded and leads Tesla, SpaceX, and the Boring Company. Tesla specializes in electric vehicle manufacturing, and they are already redefining the auto industry. In the next 10 years, the auto industry will undergo a profound transformation. The cars it builds, the companies that build them, and the consumers who buy them will look significantly different. Once found only in science fiction, fully autonomous cars are being tested on roads today, and the first commercially available autonomous cars could be on the road in the next 1 to 2 years. Connected cars, communicating with each other and with the larger world, will not only reduce accidents and ease traffic, they will have powerful effects beyond the auto industry. Insurers, for example, will have new ways to monitor driver behavior, reward good drivers, and distribute costs to the bad ones, and ride-sharing companies can better connect idle cars with the customers that need them. Another company that wants to revolutionize the autonomous driving is AutoX, a self-driving car tech startup backed by Alibaba. According to Zhao, CEO and founder of AutoX, the pandemic has made our society realize that we need self-driving cars for situations like this. Robotaxi with its self-disinfecting capabilities and driverless logistics could save lots of lives. On other industry that will be most heavily affected by the rapid technology changes such as Internet of Things and cyber-physical systems is the manufacturing industry. Smart machines can work with humans for co-assembly tasks, but they can also operate autonomously and communicate directly with manufacturing systems. Leveraging the capabilities of the Internet of Things, these machines are able to access highly computing resources and carry on work beyond what they are initially programmed to do. By evaluating sensory input and distinguishing between different product configurations, these machines can solve problems and make decisions independently. This will have a strong impact on the factories of the future. For example, advanced manufacturing processes and rapid prototyping will make possible for each customer to order one-of-a-kind product without significant cost increase. Collaborative virtual factory platforms will drastically reduce cost and time associated to new product design and engineering of the production process by exploiting complete simulation and virtual testing throughout the product lifecycle. Advanced human-machine interaction and augmented reality devices will help increasing safety in production plants and reducing physical demand to workers. Machine learning will be fundamental to optimize the production processes, both for reducing lead times and reducing the energy consumption. Cyber-physical systems and machine-to-machine communication will allow to gather and share real-time data from the shop floor in order to reduce idle times by conducting extremely effective predictive maintenance. Agriculture industry is also experiencing a fourth revolution triggered by the exponentially increasing use of information technology. This industry has seen many revolutions, whether the domestication of animals and plants a few thousand years ago, the systematic use of crop rotations and other improvements in farming practice a few hundred years ago, or the Green Revolution with systematic breeding and the widespread use of man-made fertilizers and pesticides a few decades ago.
There's actually a local company. I attended a technology trade show in Guelph here, actually now about a year and a half ago. If you don't know the area, Guelph is very big on agriculture, technologies, and so on. And so local company had developed this sensor bar that would be connected to the back of any kind of a farm tractor or vehicle that would drive up and down through the farmer's field. And this sensor array in this thing was actually a technology I have no understanding of. It was based on a sort of a crystal structure that would react to the properties of the ground somehow. And I mean, way beyond my understanding, but it could detect different constituents in the earth, like phosphorus and nitrogen, moisture contents, and so on. There are all kinds of these different constituents. So like at least a dozen different things that it could sense. And so the idea was you would drive up and down your field, and then it would create a map of your agricultural land, and it could show you have poor phosphorus over here, or you have too much of a acidic, your pH is too high or too low over here, or you have, here's the underbed creek that you can't see, but here it is weaving its way underneath your property. And so as a farmer, you can make decisions about, where to fertilize, where to correct. You can understand, why does your crop not grow over here? Why is it better over there? You could figure out where to develop, or where's the best place to put tobacco versus soybean versus peanuts versus whatever, right? And so you can make intelligent decisions based on what's going on underneath underneath the ground. there's other companies that I saw that were demonstrating using satellite imagery to look at, land formations and make estimations about soil conditions and that sort of thing. So the agricultural environment is also being, massively changed by all of this. Not necessarily, well, in their, not so much the Internet of Things, I suppose, but in terms of, artificial intelligence and sensing devices and so on.
Must be a kind of a visual thing that when the tractor passes, they already know what kind of ground it is. Must be sensing the visual way where the grass is growing or where there are stones or
not at all. It's some crazy atomic reaction between the elements that they've loaded inside this bar. It's not. It wasn't visual at all. It's a very, I don't know. It's way beyond me, but it's cool.
As the world's population booms towards 9 billion by 2050, the demand for agricultural products, food, fibre and fodder will rise dramatically. There are several smart solutions that can be implemented and scaled up in order to improve yields and meet growing food production demands. IoT sensors for light, humidity, temperature, soil moisture, crop health, etc. enable farmers to monitor the field conditions from anywhere.
If you'd like my help and a real deep dive into how do you calibrate a world-class.
They can also utilize intelligent drones to track the routine activities of crop health and analyze vast amounts of data in seconds. With the ever-growing amount of data in every industry, the need to safeguard and manage the sensitive data has increased dramatically. Many countries are already implementing strict regulations, a trend that is likely to continue into the foreseeable future. Today, there are privacy concerns with respect to who receives the data and what is done with it. However, in the coming years, we could see an increase of decentralized technology adoption of protocols such as the IoT Tangle protocol, which enhances data security, integrity, and privacy for machine-to-machine communication. This, however, deserves a video of its own. Thanks for watching. Did you like this video? Then show your...
Okay. It's kind of fun. I just realized the 3 ads that popped up while I was watching this are all promoting courses from a gentleman called Robin Sharma. He's a leadership coach and speaker, and I was reading a little bit about Robin Sharma yesterday when I was putting together course material for my leadership course. So of course that's those are the advertisements I'm seeing. Frightening. Okay, so that's let's see, is that, yeah, that, so I don't know. Do you want to have any discussion, any thoughts about what I'm showing you? Does anybody see, I guess what I'm particularly interested in, does anybody see themselves using the Internet of Things in your career path? Do you think that this is part of what the sphere you're going to be working in the next 5 or 10 years?
Yeah. Right now we are using it to complete our assignments, homework.
Okay. Yeah, I'm gonna get you into it whether you like it or not.
And definitely, I'm a person who's very interested in sort of the biomedical sphere of engineering right now, and I think that the sheer volume of sensors on the planet right now is 100 times what it was even like 10 years ago, right? So I think that it's huge in that area, and it's really important to stay on top of it, to understand like how can you get information about patients and to patients the most efficient way.
Yeah, exactly.
Only if we can look into their brain, like thoughts, then it's possible.
Well, but you don't even need to do that. Like simple things like glucose monitoring for people with diabetes, or for the elderly, to extending quality of life, so that they don't have to, they don't have to be in a long-term care facility. They could live at home, but they're wearing a smart bracelet or a smart pendant, or even an embedded sensor so that they can't lose it. You can't forget to put it on, that kind of thing. And they can go for walks. And if they get lost, then there can be some gentle guiding to lead them home, or somebody can go and retrieve them, kind of thing. Or their health is being monitored all the time. So if they fall, the device knows, so this, oh my God. So
I wish I was 30 years younger.
Yeah, if you were 30 years younger, you'd live 80 years longer.
A project happening at my undergraduate university that I thought was really cool was to help people with Alzheimer's and dementia know what's next in a task. There was like a sensor like above their bathroom sink, because something that happens a lot with people with sort of advanced age is they'll start doing something and forget what's happening next.
Yeah.
So they put a sensor over this person's sink to be like, okay, if she's been washing her hands for a minute straight, a voice pops up that just says, turn off the water and dry your hands.
Right.
And it made a huge difference. It was such a small thing, but it meant that she wasn't washing her hands for an hour.
Yeah, that's lovely. That's beautiful. And then the idea is, the concepts are so simple, but they can make such a huge difference. Like that. And I love the opportunity to put together this course, because all this is kind of holistic, we're looking at the Internet of Things, so the connectivity of devices and actuators, but then it generates in big data, and we'll talk about data analytics and that kind of stuff. Then you bring in artificial intelligence to, what do you do with the data? Simulations to work in alternate sort of methods of doing things, twin technologies, that kind of stuff. Like, it's great. Okay. Anyone else see a future in this for themselves?
Data is like a gold mine. Whoever gets their hands on it, bingo.
It is a gold mine. It's absolutely a gold mine. Yes. Yeah, no question about it. Well, then, sort of related, if you've seen the news, just 2 weeks ago, 1 or 2 weeks ago, Fitbit announced that they'd been acquired by Google. So now, like, Google is one of the huge players in the artificial intelligence market. And so for them, it is about, data and using AI to analyze data and understand human behavior and so on. And so now, by acquiring Fitbit, Google gets to the data stream that now Google gets to have access to is human behavior, like physical behavior. Where do you go? How far do you go? How do you get there? How fit are you? What is your heart rate? Did you get excited when you watched their ad? I mean, can you imagine, right? You're wearing a heart rate monitor, and you're watching, you're in Google and you're in YouTube and you're watching a video, and it will actually know whether you like or dislike the video by following your heart rate. Like, I mean, okay.
Again, they'll use those data to make ads.
Of course, but it's going to go way beyond that. Okay, so all right, let me switch gears. I want to talk about our assignment. In fact, here. So I'm going to stop recording for a moment. Thank you very much for that.